This is a Seeking Delphi special edition, highlights and overview of the 2019 Undoing Aging Conference. I'm Mark Sackler. The future lives here. From the 28th through the 30th of March, many of the world's top researchers and thought leaders in the quest to end human aging met in Berlin, Germany for the second annual Undoing Aging Conference, sponsored jointly by Aubrey de Grey's SENS Foundation and Michael Graves' Forever Healthy Foundation. I was fortunate enough to be there and to listen to dozens of presentations on groundbreaking efforts to stop and even reverse human aging. Just a few of the technologies highlighted included a vaccine for Alzheimer's disease, a gene therapy for atherosclerosis, epigenetic reprogramming of cells, regeneration of neurons, and a means of actually measuring the aging rate of cells called the methylation clock. The latter holds forth the promise of cutting the time frame for evaluating anti-aging therapies in humans from decades to perhaps as little as 1 to 2 years. But for all of this, Seeking Delphi is not about the minute scientific details of disruptive technologies. It's about the societal implications. And while the Undoing Aging Conference was almost entirely about those scientific details, one overriding message that points to the implications came through loud and clear throughout the program. This is not fringe science. Undoing aging research is moving into the mainstream, and all signals point to go. This sentiment was expressed by Jose Cordeiro in what amounted to a brief early morning pep talk to kick off the Friday morning session. Cordeiro is a director of the Millennium Project, a founding energy advisor to Singularity University, author of La Muerte de la Muerte, which is Spanish for the death of death, and most notably a candidate for the European Parliament from Spain. I asked him to sum up his thoughts for our audience. Jose, for my audience, which is a general audience, not a scientific audience, what is, just briefly in a couple of minutes, what is your message about aging, about La Muerte de la Muerte?
That we are in the brink of scientific discoveries that will let us rejuvenate people. Just like over a century ago we couldn't fly and now we can fly, or half a century ago we couldn't go to the moon and now we will be able to go to the moon quite often in the future. Well, the same will happen with aging. We will be able to stop aging and reverse aging, which is so important. This is actually an engineering problem, I think. It's not a traditional medical problem or a traditional pharmaceutical problem, because now that we have sequenced the human genome, we can understand how we age, which are the genes implicated, and we also know that we not only have genetics, we have epigenetics, and changing a few genes, you can rejuvenate cells. So biological immortality is actually possible. That doesn't mean that you will not die, because if a piano falls on your head, you will die, or if you have a car accident, but we will be able to control aging and stop aging. And I want people to know that this is possible, this is science and technology.
Very briefly, what do you say to those people that still, of which there are many, like my own family members who I argue with, who still suffer from what Aubrey calls the pro-aging trance?
It is a tragedy that some people actually are expecting to die, because obviously until now everybody died. Every human, not as certain organisms like hydras that do not age. They are also biologically immortal. Or some cells in our bodies like stem cells, germ cells as well, they do not age. And cancer. Most people do not know, but cancer cells are considered biologically immortal. And this was discovered in 1951. And today we are in 2019, and most people do not know that basic fact. So I repeat, in 1951, a long time ago, the scientists have discovered that cancer cells stop aging. That doesn't mean that they are always or truly immortal, because if you kill the cancer cells, they die, but they do not age, and that is the important thing. Cancer cells do not age, and those cancer cells discovered in 1951 are still alive today. The patient died of cancer, but the cancer cells themselves are alive. They are the most famous cells in biology. They are called HeLa cells in honor of Henrietta Lacks, that was the patient who died. Those cells are basically 1 century old, but they are perfectly young.
So now you're running for Parliament, in part because of much on this platform of ending aging. So just very quickly, though, to what extent have you thought about the social and political implications of ending aging?
Well, they are going to be fantastic, because we are going to be able to live indefinitely young, not indefinitely old. People don't want to be old, and the problem of being old is that it is very expensive to be old in terms of medicine and treatments. But if you are young, then you don't have all those medical expenses, and also you feel good and you can do anything. So the objective is that we stay indefinitely young. This will actually reduce the medical costs, not increase them. Will reduce, and also people will feel well. We will be in good physical shape. So I advise everybody to learn more about this and to join my movement in Spain or in other countries. This is a global trend. People are realizing that ending aging, and even better, undoing aging is possible. It is a matter of time. I believe that in 2 to 3 decades at most, we will be able to stop and revert aging.
But pure science isn't the only obstacle to attaining super longevity. There remain regulatory issues, and of course, there's always the need for money to fund research. The opening keynote address from Nir Barzilai of the Albert Einstein College of Medicine underscored where issues still exist. He's been the driving force behind trials to prove anti-aging properties of the diabetes drug metformin, and funding and regulation have been a major part of the process. I asked him to elaborate on this theme for us.
This metformin project is to thread needles through really difficult things. The first thing that we've done, we met together. We got a grant from the NIH to have geriatricians and biology of aging people to talk about each other and educate the biologists, educate what can be done, and the geriatrician in what are the challenges in doing a clinical study. And I got a fund to bring those people, and we brought them to a parador in Spain that's very isolated, and we called it a French jail. We were isolated, but the food was really good. and we sat together for 4 days, and we came up with some ideas, and one of them was to do TAME. And the idea was that we do TAME to prove the concept that aging can be targeted, but we do TAME in order to do the regulation. And we thought, if we're a bunch of scientists that are going to the FDA without pharmaceutical behind, because we have a cheap generic drug, and this drug is on the FDA website, so we don't have to talk about this drug. We just have to repurpose that we could make waves. So we asked to sit with the FDA, and I have to tell you, like Aubrey said yesterday, the FDA wanted to learn, wanted to see if it's possible. And the issues, there are 2 issues that we had to discuss. One issue is, what do we call this aging? Because none of us wanted to say that aging is a disease. And we came up with the solution that we are preventing a cluster of age-related diseases. And this is good enough to say aging, because that's the study that we will do. The second thing we said, well, okay, this is how we're going to do this study. Tell us what's your comments, because we don't want at the end of the study for you to come and say you should have done something different, okay? And so we got their comments. Now, of course, the study has to happen. It's not that the FDA approved. The study has to have results, and the results will be reviewed by the FDA, but at least they say, yeah, we would, if you have these results, we would absolutely consider them. So that's a hurdle. The next hurdle was to get funding from them. There's an investor that wanted to give half the money and wanted the government to give half of the rest of the money, which we thought is going to be no problem. But it didn't go well at all. It didn't go well because of problems with the NIH. First of all, there are lots of departments and not everybody likes it. Second, the review process is difficult when you have a project like that, when everybody almost in the aging field is involved. We have 14 centers with the major players, with the biologies of aging. Everybody is on conflict. It's hard to get a panel that's not on conflict. And since we suggested that we're going to prevent the cluster of cancer and Alzheimer and heart disease, the reviewers that came in were like, are you out of your mind? Aging? You think you can prevent aging? You know, what are you thinking about? There's also something inherently wrong with the way the proposal works. It's called a U19. It has an introduction and projects and cores. And the reviewers grade the project and cores, which means if they're busy, not everybody's going to lose the introduction. And the introduction was actually a great introduction to take them through our thought, our process, what we did, how. And they didn't read it. And by the way, when we said, you know, this is with the FDA, they said, we don't care about the FDA. You'll do what we want you to do. So it was very frustrating. So we went second time with a letter saying, you know, they didn't have the expertise, those reviewers. They certainly didn't have the expertise in biology of aging and in geriatrics. And we rearranged the aims. So one aim is the diseases, but the others are the geriatric aims and the biomarker development aims. And they still left the same panel. So we got basically the same thing. What are you doing? If you want to prevent, if you think one drug is doing it, do a study for cardiovascular, do a study for that.
Would you say, to summarize it basically, would you say that effectively right now the money and the regulation is a bigger hurdle than the science?
Right. So what we're doing, what we decided to do is to go back to private people through the American Federation of Aging Research. We kind of lost some of them because non-for-profit wanted to do something innovative that the NIH think is risky. Now, of course, now we have on paper that the NIH thinks it's risky. They ask, what if it doesn't work? Well, if we knew it works, I didn't have to do this.
I found it a bit curious that Aubrey de Grey chose Nir Barzilai's talk on the metformin trials for the opening keynote. When Aubrey first joined me on this program in December of 2017, he seemed to be skeptical of calorie restriction mimetics like metformin. So I asked him to clarify his stance on the subject and reasons for the choice.
Well, so my basic feeling is that at the moment, metformin is looking like a promising calorie restriction mimetic. It inhibits an enzyme called complex 1, which means that it acts to slow down the rate at which we can extract energy from nutrients. So it kind of tricks the body into thinking that we are in a famine. Now, of course, real famine in the laboratory is called calorie restriction, and for nearly a century it's been known to be very effective in increasing longevity of laboratory organisms. But it's also been clear for a long time now that longer-lived species have less benefit from calorie restriction. And we would therefore also expect that they will have less benefit from drugs that trick the body into thinking it's on calorie restriction. So that's the main reason why I think we should not get too excited. And this is not just in relation to metformin, of course. This is also with regard to other calorie restriction mimetics like resveratrol or rapamycin and so on. But that doesn't mean that I think that we shouldn't be looking at them at all. I don't think they're a waste of time at all, because the clear evidence is that they cause improvements of health, especially when you're not living in a laboratory in a controlled environment, but rather when you're making choices about what you eat and things like that. So yeah, I'm all in favor of these things, but I think we just need to always maintain a sense of proportion and remember that they are just a stepping stone to what we really want, which is proper rejuvenation biotechnology.
The fact that just about everybody at the conference agrees that stopping and perhaps reversing aging is bound to happen does not mean that everyone agrees as to the best way to make it happen. The first day of the session ended with a debate of sorts between Aubrey de Grey and Vadim Gladyshev of Harvard University. They agree that we can make progress against aging, but Gladyshev is not a believer in Aubrey de Grey's overall approach. I asked him about it.
Well, in general, I'm very optimistic about research on aging and optimistic about extending human lifespan. So it boils down to the question, what's the best way to do it? Yes? And so here we have some disagreement. So I think because aging really involves accumulation of damage. And so we can deal with this damage by dealing with the entire damage forms, whereas Aubrey suggests more like a divide and conquer approach. Kind of identifying every damage form and dealing separately. I think just damage forms are too many. It's impossible to deal with all of them individually. We need to deal with them in their entirety.
Do you really think that it's going to be possible to find a universal solution to the damage? You think we need to deal with all of it? Is that
nature has found it, because we know that many unicellular organisms, they don't age, so they are able to dilute their damage. So in the same way, stem cells can be proliferated for a long time in culture, or germline in mammals also doesn't age. So there are many examples, and we know how they work, and so the idea is to use these particular strategies in the lab.
So you think that might be transferable to large organisms?
Well, principally it can be transferable, but we could potentially rejuvenate only subsets of the organisms, because there are other elements of the organisms which, like once they are formed, I mean, like lens in the eye or like neurons in the brain, they are just there for the entire life once they are formed. And nothing can be done unless you replace a lens or brain, which would be difficult.
Aubrey simply says his approach is doable, that progress is being made on multiple fronts, and he doesn't really have that much to add. Other than that, he does not believe he and Vadim are really that far apart.
Well, I can't really say any more about why I'm more optimistic than what I said on stage. A lot of this is very subjective. We just have to estimate things, but we have to take so many things into account. That came up yesterday. The amount of interaction between the different types of damage, the amount of overlap between the techniques that will be required to repair those types of damage, all of those things, and the things we don't know, which of course Vadim also mentioned. Basically, as you could tell, we agreed very strongly about almost everything, and so you kind of expect that when there is a disagreement about the conclusions, then there's not really any, fundamental misunderstanding or anything. It's just that, everything is a little bit subjective. I don't think there's really very much more to say.
Fair enough. But Vadim did say rather emphatically that he believes negligible senescence will never be fully achievable. And as for the notion of not being able to replace the brain, that brought up another question I'd been meaning to ask Aubrey for some time. We may be able to grow new neurons in the brain at some point in the future, but the capacity of our biological cranium has still got to be limited. And if we achieve a substantially increased lifespan, perhaps an unlimited one, won't we need more capacity for memory, even if that capacity requires some sort of brain-machine interface?
So, the thing about memory, you see, is that even by today's middle age, or even probably early adulthood, we're already forgetting things just as rapidly as we are learning new things, because that's the way memory works. Memory is a kind of hologram, right? We don't store individual memories in individual synaptic connections. It's all distributed, which means that whenever you remember a new thing, the things that you already knew are just fractionally less clear, less precisely remembered. And the only reason we remember anything from a long time ago is because when we recall a memory, that process reinforces the memory. It's kind of as if we were learning it for the first time almost. So we forget things all the time, but the things we forget, it doesn't matter, because those are the things that the memories we're not using. So, I mean, today, for example, I can only remember the names of half the people I was at school with, or less, and that doesn't bother me in the slightest. And so it's already at equilibrium, in other words. And, you know, if we're 300 years old then, and we only have the same amount of memory, that's going to be fine. It's going to be distributed over a longer period of time, but we're still going to be able to remember our mother's name because it's something that we recall periodically.
I must say I disagree with Aubrey on this point. I realize there's no need to remember everything, but if we're going to live, say, 3 or 4 times longer than we normally do now, won't there be 3 or 4 times as many things we'll want or even need to remember? One thing Aubrey did agree strongly with me on, though, was my overall impression of the conference as a futurist.
Clearly, from my viewpoint, it's pretty evident that it's happening. Would you say that it's a reasonable takeaway?
I certainly would, yes. I think that what we're seeing is all of the historical obstacles, the scientific ones, the regulatory ones, the attitudinal ones, the financial ones, all of these things are indeed crumbling. And of course, that doesn't mean we're there yet. It means that we should be redoubling our efforts to continue to accelerate progress. But it certainly gives very, very strong cause for optimism that we don't have long now to wait before we really get there.
The fact that the conference was sold out and will move to a bigger venue next year adds credence to Aubrey's words. For me, though, if the barriers of science, regulation, and funding are indeed falling away, then all the more is there need to accelerate focus on how our civilization will deal with superlongevity when and if it comes to pass. Later this month, to that end, I'll be attending the Longevity Impact Roadmap workshop in Culver City, California. It's sponsored by Peter Diamandis and the X Prize. Keep listening for more information on that. My thanks to Aubrey de Grey for helping to arrange my attendance at Undoing Aging 2019, to Jose Cordeiro for connecting me with the X Prize workshop, and of course, to you for joining me. Don't forget that you can subscribe to these programs on YouTube, iTunes, or Player FM, and you can follow Seeking Delphi on Facebook. My technical assistant has been Mohammed Maroof, and until next time, I'm Mark Sackler.